So, hi everyone,
Everyone,
myself Karthik Selvam.
and myself S. Ambarasan.
So, we are pursuing final year in Mukoslang Engineering College in EC department. So, our topic is our project title is FPGA implementation of elliptical cryptography for entity authentication, and our main objective is to use elliptical cryptography to achieve entity authentication between key fob and the car.
So our main objective is to implement a dedicated hardware for elliptical cryptography to achieve the entity authentication between the key fob and the car. So these are the disadvantages of the existing method. So one of the popular attack that is known as roll jump wireless attack has been implemented in the today's present system, and other disadvantage is that the present system has smaller key size, and we can use a replay attack to attack the present system. The advantages of our system when comparing to the present existing system is the ECC, which uses smaller key size and it provides good security, and the ECC is it uses public key cryptography. That is one of the main advantages of the present system, and we can't make duplicate key, and the secret key, we can't get the secret key from the transmission of data. So we observed that an attacker can develop a device to attack the present existing system, and our developed proposed system give a solution for the attack, and these are the operations that is done in the key fob side. So the operations are ECC crypto processing, secret key generation, public key calculation, and decryption of the encryption nonce, and these are transmitted and received with the help of the transceiver module. In the car side, the receiving the public key, encryption of the random nonce, receiving the decrypted nonce, and verification of the nonce generated. And these are in the car side, the transmission and reception can be done by the transceiver. So this is the workflow of our proposed system. So at first, public key is generated and it is transmitted to the car with the help of the transceiver system. So once the public key is received by the car, it generates a random nonce and it is encrypted with the help of the public key, and it is transmitted to the key fob. And in the key fob side, the decryption of the encrypted nonce takes place. The decryption takes place with the help of the private key generated by the key fob. Once the decryption of the nonce takes place, the key fob transmits the plain text to the car. Once the car receives the plain text, it matches or it compares the received plain text with the plain text that is generated at the start. So once these are equal, the car send a signal to the door. Car send a signal to open the door. Otherwise, the car door will. These are the modules that are present in the key fob. These are the modules that will be present in the car. So these are the architecture for point addition and point doubling. This is the architecture for left shift and register adder. So these are the parameters that we are currently using in our proposed ECC system. So these are the software and our hardware used that we are using in our ECC system. This is the algorithm that we are using in our ECC system. This is the simulation result for the public key calculation. This is the simulation result for the entire encryption calculation. So here we are encrypting the message 16 and 4. So this is the simulation result for the decryption system. Here we are getting the encrypted message 10 and 4 in hexadecimal values. This is the simulation result for the point addition module. This is the simulation result for the point doubling module. This is the overall architecture for point addition. This is the overall architecture for point doubling. This is the architecture for point calculation. For point calculation, we need to the result of the point calculation will be of two coordinates, x and y. At first, it will be x3. The x coordinate will be x3, and the y coordinate of the point will be the y3. That is the output of the point calculation.